The next topic which I would like to discuss is about the corrosion control methods. The corrosion can be controlled by one of the method, that is cathodic protection. The principle which is involved in case of cathodic protection is the base metal is forcibly made to behave like cathode. Base metal in the sense the metal which can be easily affected by corrosion. That metal you call it as a base metal. So in case of cathodic protection, we convert the base metal to behave as a cathode. We always know that at anode oxidation takes place, whereas at cathode reduction takes place. If a metal is undergoing oxidation, a corrosion takes place on a particular area of a metal. Whereas in case of if a metal is metallic part which act as a cathode, then that remains unaffected. So in case of cathodic protection, the base metal is forcibly made to behave like a cathode. That you call it as a cathodic protection. So the cathodic protection is being classified into two types, that is sacrificial anodic protection and impressed current cathodic protection. So in case of sacrificial anodic protection, the base metal which is affected by corrosion, that base metal is being protected from corrosion to occur by connecting the base metal to a more active metal. Through an insulated wire, we just connect the base metal to a more active metal, such that more active metal in the sense zinc, magnesium, aluminum, these are some few of the metals which possess higher oxidation potential when compared to that of the base metal, such that entire oxidation takes place upon a active metal, leaving the base metal unaffected. So in this way, the active metal acts as an anode, whereas the base metal acts as a cathode on connecting the base metal with that of an active metal. So in case of sacrificial anodic protection, there are few examples like here. I've taken a ship. These are the underground pipeline. So we need to protect the underground pipelines from corrosion. Let us consider this underground pipeline is made up of iron. So iron is a base metal over here. In order to protect this iron metal, I'm connecting this iron metal with that of a most active metal like magnesium through an insulated copper wire, such that magnesium is a metal which possesses higher oxidation potential when compared to that of iron, such that upon a magnesium metal undergoes oxidation at a faster rate when compared to that of iron. So in this way, the corrosion usually takes place upon a iron magnesium metal, leaving this iron metal unaffected. And there is one more example which comes under the sacrificial anodic protection, like the ship hulls. The ship hull part always been exposed to the water as well as atmospheric conditions. The hull part gets easily corroded. So in order to protect the hull part of the ships, we need to connect the hull part of a ship with that of a most active metal. So the hull part of the ship is being connected with a more active metal, either with a zinc or else magnesium, such that entire oxidation takes place upon a zinc metal, leaving the hull part unaffected. So these are the two examples which you can give under the sacrificial anodic protection. So one of the most important thing which we need to remember under the sacrificial anodic protection is the base metal which is to be protected from the corrosion to occur. That metal is being connected with the most active metals which possess higher oxidation, which possess higher oxidation potential, such that the base metal tends to behave as cathode and the active metal tends to behave as an anode. Next, the second one which comes under the cathodic protection is impressed current cathodic protection. So in case of impressed current cathodic protection, as a metal, whenever a particular metal is undergoing corrosion, some corrosion current will be developed. So in order to nullify that corrosion current, through an external source, we supply a current and then nullify the corrosion current which is being obtained. So once the corrosion current is being nullified, then the metal which undergoes corrosion that can be protected from the corrosion to occur. So generally, the anodic metal may be either an inert metal or one of the one which deteriorates that gets replaced periodically by the most active metal. And here, the most commonly used anodic metals are graphite, carbon, stainless steel, iron. So these are the most commonly used anodic metals.